isn't official lesson in the book on inverse functions, but it's something that is going to be part of the AP curriculum this year. So we're going to do a kind of one-off lesson on inverses. And so we need to just kind of be reminded of how we define an inverse function. So let's start out with a regular function. Let's say if a is on the function f of x, then let's assign its y value. So f of a would be defined as b. Okay, so a is the x value, b is the y value. So then by definition of an inverse, the inverse point is on the inverse function. So if b is on g of x, then g of b must get you back to a again. Okay, so that's the classic definition of an inverse. What goes one way is undone to get you back the other way. So think about, like, on a parabola, it's 3, 9, right? 3, 9 is on a parabola. But on a square root, the point on the square root is 9, 3. A parabola and a square root are inverses of each other. So for notation, let's define g of x as the inverse function of x. So what's new is now how do we find the derivative? So let's find the derivative of g with respect to x when x is b. So we're going to use the idea of composites and the idea of the chain rule to help us develop the derivative. Just a caveat so you know, you don't have to actually find the inverse function to find its derivative. It's a beautiful thing where you don't have, sometimes inverse functions are almost impossible to find because the original function is so complex, and so the inverse function would be almost impossible to find, but we can find its derivative without needing to find the inverse. So let's start with this. We're going to develop the derivative. So if we start with the definition, we're saying that g of x is defined as f inverse of x. And then if we apply math to both sides, so let's apply the f function to the right side, and let's apply that same f function to the left side. What we're going to get is we're going to get f and f inverse undo each other, and you're left with simply x. And then we've got f of g of x on the other side. This is an expression that we can use the chain rule to find the derivative for. Remember, we are looking for the derivative of g. Let's find the derivative of this composite function first. So we're going to work outside in. So we're going to start with the derivative of the outside. So that would be df dx, while we're leaving the inside alone. Then the chain rule says, okay, then do dg dx, the derivative of that, leaving that inside alone. And then the derivative of the inside of that is 1, and then the derivative of x is 1. And what we are looking for is we are looking for this expression. We want to know what is dg dx at a particular value of x. And so in order to isolate that, we'll say, okay, well, dg dx of a particular value of x is going to be 1 divided by df dx of a particular value of g. We just use division on both sides. And the particular value that we want is when x is b. So dg dx at the b value is going to be 1 over df dx at the particular b value. And if we look back up near the top a little bit, g of b at the beginning up here, g of b is equal to a. So that means we can come back and say, oh, well, I can replace then this g of b with a. So dg dx of a particular value of b is equal to 1 over df dx of a particular value of a. It might be easier to see it in Newton's notation instead of Leibniz. So let's convert to Newton. G prime of b is equal to 1 over f prime of a. And that is the development of the derivative of an inverse function. G is the inverse, and so its derivative, when using the b value, is equal to the fraction 1 over the f derivative when using the a value. And that is the development of the formula for the inverse of a function, the derivative of the inverse of a function. So let's keep that in mind, and let's try an actual question. Let me show you how that works. You don't have to develop it every time, but that is the development, aka the proof. So f of x is 7x cubed plus the quantity, the natural log of x, also cubed. And the point we're going to be looking at that actually works on that function is that f of 1, when I plug that in, equals 7. All right, g of x is defined as the inverse. And so we are going to be asked to find g prime of 7. Well, by definition, g prime of 7, which is the b value of the function, is equal to 1 over f prime of the number 1, because 7 and 1 are paired together as a point. And so I just need to know what the derivative of the f function is. You don't ever have to find the inverse, you just have to know the derivative of f. So the derivative of f is 21x squared plus 3 times the quantity ln of x, quantity squared, times the chain rule of 1 over x. And I would like to find that at the particular value of 1. Okay, that's where on a multiple choice people will get tripped up, is that they'll try and plug in the number 7. The number 7 evaluated in the inverse is the same as evaluating the number 1 in the original derivative. So this will be 1 over 21 plus 3 times 0 squared times 1, if we're plugging in 1. So we get 1 over 21. And that's the value of g prime of 7, is 1 over 21. Once you know how to do it, it's really not very hard. Let's try another one. Okay, so let's be given a different function. Let's be given the function 3x to the 5th plus 6x to the 3rd plus 4. You're also given that g of x is the inverse. And then you're asked to find g prime of 3. All right, well this one, g prime of 13, sorry. Okay, g prime of 13. This one is a little bit, I didn't give you quite as much information as last time, because last time I gave you the point value in the f function. And so before we can find g prime of 13, we need to know something else first. We need to know f of what value a would actually give us 13. We're going to have to work our way backwards to figure out what the a value is that we need to go with it. Because according to inverses, 13 in the inverse function should be the y value of the original function. So we're going to take our original function, 3x to the 5th plus 6x to the 3rd plus 4 equals 13. And hopefully, well, not even hopefully, I'll tell you, all of the problems are going to work out where the answer hopefully should be obvious to you. So you shouldn't have to, I mean, it takes a little bit of guess and checking to solve this the most efficient way, but see 3, 6, and 4. 3 plus 6 is 9, plus 4 is 13. So then it should work if x is 1. And you just need to find one value that would work. So the x value is 1. So then we can come back, well, g prime of 13 then must be 1 over f prime of 1. Now that I know the corresponding values. So that would be 1 over f prime is going to be 15 x to the 4th plus 18 x squared. And when I plug the particular value 1 in there, I get 1 over 15 plus 18, so 1 over 33. All right, the final one I want to show you sort of includes everything. Okay. Write a tangent line to the inverse of the following function: x to the 5th plus 2x to the 3rd plus x minus 4 through the point negative 4, 0. So a couple things just to clarify the way that the question goes. Negative 4, 0 is on the inverse. It's not on the original function. So if negative 4, 0 is on the inverse, then 0, negative 4 is on the original function. And we can confirm that, and that is true. And so what we need to write a tangent line is we need our point on the inverse, which we already have. Point on the inverse is negative 4, 0. And we need our slope on the inverse, which is going to be g prime of negative 4, which by definition is going to be 1 over f prime of 0. All right, that's going to give me 5x to the 4th plus 6x squared plus 1. When I plug 0 in there, I'm going to get 1 over 0 plus 0 plus 1. So I get 1 for my slope. And so now I've got 1 for my slope, and I have my point on the inverse. So my tangent line is going to be y minus 0, 1 value for slope, and x plus 4. So that was less than 15 minutes of your time. Hopefully that will help you out with the 10 questions that are on the website to have you practice. And then we'll see this come up in some FRQs, similar to how we saw it come up on the FRQ that we did on my ap.collegeboard.org. We saw that inverse part come up in part D, and I said, don't worry, you don't know how to do that yet, but now you do. All right, I'll see you on Friday. I hope you have a good next couple days. Bye.